Hello, this is my first extra credit video for physics, period FG, and that's me in the reflection of the computer. I'm not able to switch the camera around, so I kind of have to show you my face through the reflection, just proving that it's me. So I'm going to be focusing on the realm of 2D kinematics in this first video by dropping my phone from various heights and then calculating theoretically what the final velocity of it is at the instant that it hits the surface, in this case a table. And I'm going to visualize through a graph the correlation between the height at which my phone is dropped at and the final velocity. So just to illustrate, here's my phone being dropped from 2 centimeters. 2 centimeters again. Now here's 4 centimeters. 6 centimeters. 8 centimeters. 10 centimeters. 12 centimeters. 14 centimeters. 16. 18. And 20. It may not be audible in the video, or it may, but the smack, the impact of the phone and the table gets quite significantly louder as it's dropped from higher, which may indicate a higher velocity at the point of impact. Now we're going to figure that out at these different points using our lovely kinematics equations. We are going to be given an acceleration of negative 9.82 meters per second squared. We are given an initial velocity of 0 meters per second, and we are not given time. However, we do not need time in order to find this, so we will ignore it. Our delta x will vary. We will start with 0.02 meters, then 0.04 meters, 0.06 meters, 0.08 meters, and 0.1 meters, 0.12 meters, 0.14 meters, 0.16 meters, 0.18 meters, and 0.20 meters. And that's going to be 10 different values, which should provide us with a decent representation when I translate this into a graph. So we're going to use the equation number 5 because every other equation has t for time incorporated in it. So we'll just write vf squared equals vi squared plus 2a delta x. Now, the only things that will be changing, of course, are vf squared and delta x, so which is the displacement. So we are going to just completely ignore initial velocity because that's 0. So vf squared equals 2 times negative 9.82 times delta x, which will also be negative. So we could just cancel out the negatives and call delta x positive. So that would be equivalent to the square root of, got my calculator here, 19.64 delta x. So now we're going to find the final velocities at each of these different drop heights. So I will do that, and I will get back to you.